What if there is a massive hurricane behind you that will soon make landfall? And a massive tornado is directly in front of you and is moving quickly in the direction of the rival storm. And you? The time is up. Escape is pointless. How do hurricanes develop? When a weather disturbance, like a thunderstorm, moves over water that is warmer than 26.5 degrees Celsius 80 degrees Fahrenheit, a hurricane is created. Cooler air rushes in to fill the low air pressure zone left by all that hot air being forced upward, producing ferocious winds in the process. The storm draws hot, humid air from the warm waters, and condensation continuously feeds the hurricane with more and more clouds. Hurricanes are tropical storms with winds of at least 119 kilometers per hour 74 miles per hour, which form in the Atlantic Ocean. The eyewall, where the winds and rains are strongest, the rain bands that spin out from the center and give the storm its size, and the calm center of a hurricane are the three main components. When a storm brushes against or collides with land, it frequently has the greatest impact on coastal areas with strong winds, heavy rain, and storm surges. The Saffir-Simpson hurricane wind scale is used by meteorologists to categorize hurricanes into 1 to 5 different categories. Major storms are categorized as being in categories 3 to 5. The strongest of them, a Category 5 hurricane, travels at a speed of 252 kilometers per hour 157 miles per hour. Likewise, it carries the risk of catastrophic damage accompanied by storm surges up to 8 meters 19 feet in height. A tornado follows that. When warm, humid air and cold, dry air collide, a tornado is created. Thunderstorms are typically produced when the colder, denser air is forced over the warmer air. An updraft results when warm air rises through colder air. Winds that abruptly change in speed or direction will cause the updraft to start rotating. The mesocyclone, a rotating updraft, picks up more warm air from the storm as it moves, speeding up its rotation. Even more energy is provided by the cool air fueled by the jet stream, a powerful band of wind in the atmosphere. A funnel cloud is created by the water droplets in the moist air of the mesocyclone. The funnel keeps expanding until it emerges from the cloud at some point. It transforms into a tornado once it touches the ground. A tornado is an air column that extends from a thunderstorm to the ground and is rapidly rotating. A gloomy, greenish sky frequently heralds it. Dark storm clouds are gathering. Hail as big as a baseball could fall. Unexpectedly, a funnel appears as though it were coming out of a cloud. With a sound like an approaching freight train, the funnel roars forward as it strikes the ground. Everything in the tornado's path is destroyed. Supercell thunderstorms, which are large thunderstorms with winds already rotating, produce the most violent tornadoes. 1 in 5 or 6 supercells and 1 in about 1 in 1,000 storms produce tornadoes. A tornado's lifespan after it strikes the ground can range from a few seconds to 3 hours. The typical tornado is 60 feet wide and travels at a speed of 30 miles per hour. Most species only survive for 6 miles or less. However, large tornadoes, the ones that can cause significant damage and many fatalities, can move at speeds of up to 300 miles per hour. The width of a tornado can reach 460 meters, 1,509 feet. Additionally, despite having an average lifespan of less than 10 minutes, they can have destructive winds of up to 320 kilometers per hour, 200 miles per hour. Which of these two is more powerful would determine a significant portion of this contest. A tornado's winds can be more powerful than a hurricane's in terms of sheer power. Yet hurricanes last for days as opposed to just a few minutes, unlike tornadoes. They generally do a lot more damage and are bigger as well. Additionally, it is not unusual for tornadoes to develop from hurricanes with their enormous thunderstorms. If you were caught in a particularly severe storm, you might even see what appears to be a large number of tornadoes colliding with one another, combining and devastating. that is referred to as a multi-vortex tornado by scientists. It's a single tornado with 2 to 5 rotating funnel clouds that have formed around it. However, hurricanes could theoretically interact with one another. The Fujiwara effect, which occurs when two objects are less than 1,500 kilometers 900 miles apart, may cause them to begin rotating around one another. Or perhaps more appropriately, the Fujiwara dance. Now, if two hurricanes approach one another within 300 kilometers 190 miles, the stronger one will be able to absorb the weaker one. When Hurricane Iris and Tropical Storm Karen made close contact in 1995, this is what transpired. Before the more resilient Iris swallowed Po Karen, the two rotated, or you could say they danced around each other. But let's move on to the interaction that brought us all here. A hurricane and a tornado squared off. How would it feel to see them merge? The scenario of a tornado colliding with a hurricane is extremely rare and complex. The collision of these two phenomena would result in a unique and unpredictable set of interactions. You would observe a rainstorm as the hurricane got closer to you. Strong winds and the ominous sound of early warning sirens would accompany it. The wind gusts would intensify until they roared. You could only communicate with other people by yelling. Sooner or later, it will be difficult for you to stay upright. Trees would sway, split, and even rip themselves out of the ground. Roofs in your neighborhood would be torn off and fly away like paper airplanes, along with that car you haven't paid off yet. Goodbye. Not that you would be able to see it. It would be nearly impossible to see anything at all because of how severely it would be raining. If a tornado were to somehow form within the environment of a hurricane, it would likely be influenced by the larger scale circulation of the hurricane. You would then notice it. The enormous tornado. The two storms would begin to orbit one another as they got closer in a spectacular Fujiwara dance-off. The two possible outcomes of this swirling whirlwind of a battle between destructive enemies would then be possible. The tornado and the hurricane are two potential outcomes that could split off from their dance and proceed in separate directions. Or perhaps the hurricane's sheer size absorbs the tornado vortex, which would not be particularly exciting. The tornado's funnel would simply dissipate and return to the sky. In this instance, the hurricane would come out on top. The hurricane's victory wouldn't even make it any stronger despite the strength of its former dance partner. But even if that's the most likely outcome, it's important to note that it is not absolute. Given the rarity of such an event and the challenges in accurately predicting the behavior of both tornadoes and hurricanes, it's difficult to provide precise details about the outcome. Tornadoes and hurricanes are both highly dynamic and complex atmospheric phenomena, and any interaction between them would involve intricate interactions of air currents, pressure systems, and other meteorological factors. As for you who would be watching all of these unfolds, who knows if you're lucky and fate sees you kindly and you'll live. Maybe you will be the one telling this tale next time. Did this catch your interest? Please subscribe to Weather Collapse if you want to know more and be updated on the latest news about natural calamities or disasters happening all over the world, and don't forget to like today's video. We'll see you in the next video. Thanks for watching.